basically, malware can be detected in two ways. Like one is the endpoint and another is the network. Okay, so network detection might not be so efficient. There might be false positive. So here, majorly, we'll talk about endpoint because most of the malware detection happens most effectively on the endpoint. Uh, so one is there are two kinds of detection we will be taking into consideration. One is the static detection, and one is the behavior detection. So ideally, static detection is a very old technology. It's there since the evolution of antiviruses, uh, more than 25, 30 years, whatever is the first antiviruses were first detected. So static detection relies on sole file scanning. So it searches for the patterns in the file. So where it fails, we discussed about previously how packed malwares behave. So you cannot detect if a malware is packed. You cannot see the patterns. Hence, uh, your static file scanning is not effective against packed malwares. And today, packed malwares are 90%, I would say, or more than that. Then comes the dynamic uh, detection. So this is some behavior detection. So this is we talked about static and dynamic analysis. In static analysis, we looked into the contents of the file. In dynamic analysis, we see the contents of a process or the impact of the process. So in dynamic analysis, we are going to see the dynamic behavior detection. We are going to see the same thing. Okay, so dynamic or behavior detection, and this is now used by EDRs. EDRs also have some part of static detection. Many EDRs they have static detection. They scan files, but they mostly rely on behavior detection. So here are a few components which contribute to behavior detection. One is memory scanning. Memory scanning is a technology which would be helpful in detecting malwares which are packed. As we saw, packed malwares unpack themselves or decrypt themselves in memory. Another is ETW or event tracing for Windows. So this can be used to log behavior of malware or anything on the system. Uh, so whatever happens on the system, like a person logged in, logged out, any files created, process created, or a registry created, everything can be logged with ETW technology. Next is AMSI. AMSI stands for Anti-Malware Scan Interface. This is a technology used to deal with malwares, which are basically uh, created using the default script Windows scripting languages. For an example, your PowerShell malware, your Microsoft Word, your macro malwares, JavaScript malwares, and VBScript malwares. So AMSI has capability to decrypt this kind of malware and gives you in decrypted form, which can be used by antiviruses or EDRs to scan. So MSI is a good thing for dealing with uh, you know the uh, scripting malwares. It doesn't support Python or all. It supports only scripting malwares which are by default supported by Windows. Next is API hooking. API hooking is a technology used in Sandbox. It can be used to accurately determine the behavior of a malware. So we saw the API logging. We were using the tools, my Malwin API logger, and after that Xlogger tool. All these tools we are using, and those were generating the API logs. And from API logs, we were able to determine what the malware is doing at the code level. And same can be used for detection. Another is rootkit scanner. So rootkits are basically, I won't say rootkits are malware, but rather they are components of malware. Again, I'm repeating, there is often wrong definition about rootkits. Rootkits are termed as malwares, but I tell that rootkits are basically components of malware which are used to hide the artifacts of malware. What kind of artifacts? For an example, a malware drops a file onto the system, a malware creates certain processes, a malware communicates with the network. So all those things like your files, process of the malware, and the network communication done by the malware can be hidden from plain sight with the help of rootkits. Uh, so rootkit scanner is a component of many of the EDRs and antiviruses engines, and they can be uh, used to detect malware as well. Okay, so rootkit is a part of behavior because it's there in the memory, then only it works. So there are two behavior components in antiviruses. One is the rootkit scanner, another is the memory scanner. So memory scanner is the one of the best methods to detect malware because malwares are somehow encrypted in memory. In PowerShell, uh, also there are malwares which are PowerShell based malware, which we often call it fileless malware. They can also be detected accurately with memory scanning. But what is the drawback of memory scanning? It slows down the system very much. That's why it's rarely used. Okay, so malwares are able to evade it because mostly it's not on, even though the feature is there, it's not on, switched on many times. So that is the problem with memory scanning. So detection technologies, two detection technologies, endpoint on endpoint, that is antiviruses and EDRs. On network, IDS, IPS, firewall, sandboxes. So what are these sandboxes? So sandboxes were designed first, become a commercial products in maybe around 2013, 14 during that time. Now it's not so much popular compared to EDRs. So these were the first things. Sandboxes were the first thing that used to detect behavior. Okay, so they rely on the technology API login. So what they do is basically they are integrated with IDS IPS product. So if you have a sandbox and there is a IDS IPS, what happens is IDS IPS would be listening to the traffic, and Suricata like IDS, they have capability to extract the files out of the network, put it in a sandbox environment. Sandbox will execute based on the logs. It will detect, and after that it will give a verdict whether the file is a malware or not. The problem with this kind of technology is sandbox are slow in analyzing the malware. They are not real time. So basically, it's just like automation, but on an average, sandboxes they analyze a malware around maybe 30 seconds or a minute or maybe 2 minutes. So the same steps what we do manually, those are automated in sandbox, but it doesn't happen. It happens in very less time, and if it is a critical malware like the ransomware, it's might get into the network and do the damage unless the sandbox alerts you. Uh, yeah, so detection and blocking. So there are two terminologies. So one is detection and one is blocking. Okay, and another is remediation. Detections means you detect a malware. Okay, so you might not block it. Uh, so for an example, ransomware can easily be detected. So ransomware are easily detected because they reveal themselves. They immediately after infection, they will tell that I have infected your system, and you can now pay, you have to pay me the ransom as of. So they reveal themselves, and they reveal, yeah, but the problem is they reveal after themselves after doing all the stuff. Sometimes ransomware can also be detected when BSS admin or BCT edit uh, commands are called for deleting the backups. But unfortunately, this is called mostly after the ransomware entered the files. So basically, you can uh, basically the ransomware can basically what will happen? It has encrypted the everything on the system, then it alerts. Okay, so we are too late. So even though we detected by basis admin, we are too late. Okay, so detection would be effective in other cases because you have time. Like for an example, if you detect a stealer, after some time doesn't matter. But ransomware, you have to detect as soon as the ransomware executes on the system or starts executing at very early stage. That is the challenge with ransomware. So here the blocking concept comes into the picture. So ransom. So every malware needs to be blocked, no doubt, but the timing in case of ransomware should be very quick. So as soon as the process of ransomware is created, it should be detected as soon as possible. Yeah. So if you cannot detect the file, fine, but if you have to detect the process as soon as it created. As of now, many are not doing it. So by behavior, that can be detected. There are algorithms like ransomware. If they encrypt certain files, certain few extensions, few files. After that, maybe they can be detected. But still, many EDRs fail to block them at the early stage. Maybe some EDRs they block the ransomware after a few seconds. Or also, we have seen cases where the ransomware has executed, and before encrypting the file itself, it has somehow disabled the EDR. Okay, so it has because the ransomware was not detected, its rest of the behavior could not be detected somehow. Before encrypting the files, it has removed, disabled whatever done with the EDR or killed the EDR. Okay, so as a ransomware bypass the EDR. Remediations means the restoring the damage done to the system. So in case of ransomware today, remediation is hardly possible. Okay. So because I told you about the technology previously, like how ransomware use a combination of public and private key cryptography. Earlier ransomware, they were mostly using symmetric key cryptography, which the encrypted files could be restored. That was long back, maybe 2014. Now it is no more like that. Other remediation are like removing persistence, file infections on the system. Like there was a concept earlier known as file infection. Okay, so basically malwares used to infect the healthy uh, binaries on the system, and the binaries will act like a malware as well as they will behave normally. So those malwares are usually called the virus. Okay, virut and sality were the commonly seen viruses. Endpoint detection, I talked about this. So we'll talk a bit about antivirus components. Antivirus, few of the components are mini filter driver. Uh, so when you check your antivirus, so let me show you here how it looks like. So this is your Defender, and in this is the default antiviruses on your system mostly. If you go to manage settings, so there is something known as real-time protection. What is this real-time protection and how does it work? So there is uh, a kernel driver, okay, which sits inside the kernel of the process. And what happens is whenever a file is getting written to the system, that time the kernel driver or kernel filter driver, more accurately, you say, it scans the file before the file is actually written to the disk. So you can say like your file is coming to the system and your hard disk is here, okay, and basically there are layers of driver which are used to write files to the disk. So basically the antivirus inserts another driver known as filter driver. So usually what happens, the whenever you write a file from any application, the application is going to communicate with the driver and the driver is going to write to the file. Okay, but when a filter driver is inserted, so it comes another layer of interception. So your file will go to the filter driver. Filter driver is connected with the antivirus's signature. Okay, so filter driver will scan the file and after that see if it has any malware signature or not. And if the malware signatures is detected, okay, then the file is blocked. Otherwise, written to the disk. Okay, so again, it is scanning of the file. So if file is encrypted and antivirus doesn't have signature, this won't be effective. Okay, so this is the real-time protection. In case of Defender, they call this real-time protection. In case of McAfee, I think they call uh, and then online. I don't. I forgot that terminology. Okay, so uh, on access protection they call it, on access scanning. Okay, so on access scanning or protection. Here it is called real-time protection. So different antiviruses term the this thing as with different names. Okay, so on access means as soon as the file is accessed before it is getting written to the disk, is scanned and written. Okay, so again this is a static kind of scanning. So here malwares might bypass if it is basically if it is encrypted. Okay, so if somebody is interested in uh, writing antivirus, so basically there are free software. Okay, the free open source code here in Microsoft website itself. Okay, so maybe later I'll share the link. uh, so if somebody is interested in writing antiviruses and EDRs, so you can uh, go to this. Okay, so Basically, this is a free. If you have to learn about driver programming, so this talks about how to write a real-time filter driver. So you can refer here. Its name is avscan.c. Microsoft provides it as an example. It might not be that efficient. You have to tune it, but it is one of the things that is used for file scanning. Okay. And what is Yara? So Yara is basically a pattern matching algorithm. So what happens is the antiviruses, this one intercept the file, it hands over to a pattern matching algorithm. This pattern matching algorithm may or may not be Yara. Okay, so it may or may not be Yara. So antiviruses engines have their own way of pattern matching algorithm. They have their own proprietary way of writing signature. Okay, so you can refer to this Yara. If somebody wants to learn about pattern matching, learn about Yara pattern matching. It's open source. There are other pattern matching algorithms as well. Okay, so Yara doesn't have these components like your AV-scan and all these things which intercept the filter. It has to get a file or a process. You have to give it an input to what to scan basically. Okay, so by default it takes process and files. These are the two things. Okay, so how does the antivirus basically works? So as I told, real-time scanner or the what we saw, there are two components here: real-time scanner and on-demand scanner. So real-time scanner comes into the picture when the file is being written to the disk, uh, and the real-time scanner scans before the file is written to the disk. On-demand scanner means you can always run the on-demand scanner against the file. So it is anytime it's a scheduled task, or maybe you manually run entire system, that is called on-demand scanning. So in on-demand scanning, maybe your memory is also scanned. In real-time scanning, only file is scanned. So what happens? So you get a file and file is sent to the scanner. So this scanner, what they do is they go to the signature engine. So what does the signature engine have? So there are different kind of files on the system, like a doc file, PDF file, exe file, all these files. So basically, your signature engine should have capability to parse all these files and extract the information of the file. So Yara, you might have seen Yara tries to Yara, it can scan the entire file as well, but scanning the entire file is not an efficient way because it creates certain problem, efficiency problem. I'll talk about that. So signature engines have file format parser, they have a disassembler, they have pattern matching algorithm. Pattern matching algorithm is a part of Yara. Disassembler also is there in Yara. So basically, after extracting the content, it can be disassembled, and after that, the file is matched against the signatures present. Okay, and signatures, if they detect, then the file is blocked, deleted, whatever it is. So there can be two ways in which signatures can be written. The simplest way is string patterns, and next is the bytes, which is on the opcodes. Okay, for opcodes, you need to understand about assembly language. Blindly picking up opcode doesn't work. Okay, so when you talk about machine learning, I think just picking up bytes doesn't work, because the problem is you don't know is the bytes of malware or not. I cannot say that any kind of move instruction is malicious or not. It cannot be determined. You have to see the code, what it does, and all the things. Okay, so I don't. Yeah, there are a lot of in academics, people do research, but practically my findings were not great against byte detection being used in machine learning. Okay, so when you think it as a product, academic, it is fine, but when you think of developing a product, might not. It caused a lot of troubles, like false positives and all. So string patterns look like this after you analyze the malware, provided it is unpacked. So this is still strings in stealer. So if you see like this, plus you find out the family of the malware, use that for strings. Use that for detection. Byte patterns are based on the bytes of the instructions. Okay. So byte patterns you have to be very accurate. So you have to see which bytes you select. Otherwise, it will from where you are selecting. That is also important. I talked about, yes, maybe the reverse engineering part. There are compiler stuff, library codes. So if you accidentally write code on the library related code, then it is going to cause huge false positive. Okay, so when it goes out in the field where detection, see, you are testing one detection, another is your detection goes out there in the field where millions of people use your signature. At that time, you should see the result whether it is causing false positive or not. Lab environment is a completely different scenario. So your detection should be working properly in the real world, okay, not in the lab environment. Write patterns. So how do you write patterns? For an example, select these set of bytes. Okay. So after that, to detect more malwares here too, basically what you need to do is basically you have to uh, provide more coverage. You cannot write detection for each and every malware file for a particular family. So basically clustering. Okay, clustering means basically you collect the malware and sort them. Similar malware, similar files, you collect them together, find out common patterns on them based on your analysis. Okay, not just like pattern matching or something like that. Based on your analysis, pick up patterns. Okay, try to see whether that pattern is there in another file or not. Okay, and if there is a pattern, are they exactly same, or what are the difference? So many of the times you will see that you have to understand instruction. For an example, E8 stands for your call instruction. Okay, assembly call instruction is there. So if there is a call instruction, is it same? So you have to check the patterns in all the collections what you have. At least most of them should have the pattern. After that, you write a signature wildcards you can use so that it covers more files. Say suppose in another file, this is some YZ, right? So in that, these two are not going to match. In that, you have to replace with wildcards. So you can see here, I have replaced some wildcards for some other things. Okay, so you have to pick up patterns. So the mostly selected patterns for writing byte patterns are mostly decryption loop specific to a malware. See what that is doing. Okay, because you cannot dig too much deeper into a basically packed file. It will uh, it will cause performance issues. Okay, so this was about static signature. Now about behavior signature. So what are behavior signature? So behavior are changes made by the malware to the system, which can be registry changes, process changes, or some event. Okay, for an example, when we talked about how a malware attacks. So malware, if it how malware is compromised. So we have seen a Microsoft Word document starts, and after that, it might launch a exe. So in this case, I mentioned Microsoft Word document power sponsor PowerShell. Means Microsoft Word document starts a PowerShell. So this is somewhat unusual in the system. A Microsoft Word is meant only to, uh, it should mostly somebody should be reading what's written into it. It should not launch a PowerShell. It should not launch a exe. Maybe AI.exe is the recent one added for some of the Microsoft one, where AI.exe is for AI purpose. That's why it's a AI module is there. Other than that, nothing else should be launched. Okay, from different location. So these are all detected by the EDRs. Any such events are detected by the EDRs. Okay, so they will try to detect based on this behavior. Okay. So for behavior signature, we use Sigma rules. So Sigma rules is just a baseline where you can refer and create signature. It might not be directly consumed as a signature in many cases, but it can be used as a reference. Other than that, see, this is a contributed from open source, many of the signatures, so they might not be so working so well. For an example, here I am telling here is a persistence mechanism that is created, but here it also tells that the persistence mechanism is created by the binary reg.exe. But malwares can create reg.exe, malware executable. They don't need to call reg.exe. Okay, so they can programmatically directly call the registry APIs and create all these things, right? So in that case, this signature is going to fail. So any Sigma rules or any open source rule, please evaluate before applying it to your system. Okay, so understand the malwares and then only apply. Okay, so this is another behavior signature which tells about which is used to detect a ransomware. So this one says that the process named VSS admin is called with the command line argument this one, and this is going to tell that the detection is related to the ransomware. Next is the memory scanning. So memory scanning is the behavior-based scanning. It is used to scan memory to detect malwares. So in my book, I've given a source code of a small memory scanning. It is present in the GitHub, so you can check it out. The GitHub report. Then okay, so how do the EDRs and all detect? how do they show the detection? So basically, whatever happened on the system, they will relate it to the MITRE ID. MITRE IDs are the baseline for detection. It's easy for somebody to track also. For an example, here Microsoft Word has started. Okay, after that, there is a process SVC host which created something like this. Okay, so this is the event. So what is the event? Event is a registry creation. What happened in the event? A registry entry was created, and to which MITRE ID it is connected to. So it is connected to the MITRE ID. This one T15147. Okay, so this is how the detection should look like in a EDR. Okay, so let me show a glimpse of a EDR. How EDR detects, how they show the output. Okay, so in the SIM, how it looks like. Can you see my screen? Is the video visible?
Yes, sir.
Okay. So basically, I have a Microsoft Word document. Okay, there is a Microsoft Word document here. So this is a malicious malicious Word document which calls macro behind and does some stuff. So here my EDR endpoint part of the EDR is installed on the system, and let us see how it looks like. So I double clicked here. Okay, so it executed, and after that it connects to a website. And as soon as I enable the macro, something happens in the backend. Okay, so exe was started, downloaded and started. Okay, so this is the event happened. Now, how does it look in your SIM? Okay, SIM. So here the EDR endpoint is there, which detects all the events. It will say that your exe has done this stuff. All your what document has done this stuff. Okay. So if you get a chance to look into the EDR, this is how it looks like. So there would be many events. Whatever happening on your system, all would be logged there. Okay. So basically, let me show you how it looks like. So basically, say suppose from the network communication, I say that there is a suspicious network communication to GitHub. Okay, I'm assuming GitHub here because my malware is connecting to GitHub. So this suspicious I'm telling. Okay, but in case of malware, it would be connected to somewhere else. So check in the SIM. So now from the network, I know okay something is happening. The SIM I know. Okay, so network things also get logged into the SIM. So let us check the network. Okay, the SIM, and after that, what happens is the SIM. This is what I see. So it shows me this particular desktop is the one from which network connection is happening, and so I need to analyze what's has happened to the desktop. Okay. So if I see here in the particular time, here it shows me what .exe started a process known as svc host.exe. Okay. So it is shows me somewhat like many of the EDR UI or the SIM, they show you something like this. You need to investigate like this. Okay. So from the Microsoft Word, svc zero host.exe started and dummy malware.exe started. Okay. So all these happen in the backend. If I click on the events, if I check on any of the events by these processes, all these things it is going to tell. For an example, SV host.exe or dummy malware, if I check the events of the EDR, so this is elastic EDR. Okay, so I've taken a trial version to show. So if I show here, it will tell me what all happened here. So basically, this process created 9 alerts. One is related to file, 4 related to network, and registry. Okay, so if I see the events, it is going to tell me what this dummy malware is doing. Okay, so it has created some registry events. Okay, so these are the registry event it created. Okay, so it shows this registry event. Okay, so it was detected and this registry event was created. So this is how we investigate detections in a SIM. Okay, so you narrow out from the network communication, check your system when that event has happened, what all have happened. Accordingly, you check it. Okay, so after this, you know what all things have happened. Check out all the So how did this detection happen? So basically, EDRs rely on the technologies I told, ETW and all the technologies to log the events happening on the system. Okay. Okay, so just give me 2 minutes. I'll be back. Yeah, so this is how the EDRs detect. Okay, so I'll talk about some one practical exercise here about EDR, about the detections. So now let me talk a bit about static detection, behavior detection. I'll show Yara how to write Yara rules, a quick view, okay, and how to write efficient rules. Okay, so here we'll give you some hints about what is the problem with your machine learning and bytes. Okay, so this we already talked about. Okay, so when you write a signature, what happens? Okay, for an example, you are analyzing a malware. In that malware, you figured out there is a pattern malice. Yeah. Okay. So now in your system, what is happening? In your system, what is happening? There are maybe thousands or millions of files, depends upon the size of the system what you are using. Okay, so but there in those thousands of files, there can be only one or two suspicious or malicious files. Your malware, your system is not going to have thousands of malicious files. Okay, so basically, there is one malware, and you choose that for writing a detection, there is a string there, and the string is malstr. Malstr is the string. Okay, so now if you write a signature, what happens? Okay, so I write a signature, and what is going to happen is there, as I told, there are clean files, one malware file is there. So just if you just scan with this signature the entire system, what is going to happen? Okay. So it is going to scan every file from starting to ending. Okay, so this will happen. So even though if it detects the malware, it will go on scanning till all the files. It will scan your entire system. You cannot tell that you stop at this. And if you are able to identify this pattern in somewhere also middle, still it is going to scan till the end. Okay. So what happens? So what happens due to this? Your system is going to slow down. Okay. So you need to tune the performance. Okay. So another thing, I talked about one rule having mal str. So in your actually when you write rules, you would be writing hundreds of rules. Okay, hundreds of rules, right, for different malwares. And obviously there is only one or two malwares on the system. Okay, now if you scan those hundreds of rules against each of the file, what is going to happen? Okay. So this once rule scanned each file, second rule scanned each file, whether it is malware or not. But hundreds of rule will be scanned like this end to end. So this causes the performance issue. Okay. So you have to limit the scanning amount of scanning for each file, number of the files to scan. You should limit it. Okay. Otherwise, there is a problem. It will slow down the system practically. Okay. So basically, how is this performance increased? Okay. So this performance can be increased by using the knowledge of file formats. Okay. And after that, it should have dissimilar components and all the things, pattern matching algorithm, all the things are there. Okay, so file format and all these things are used for the scanning. Okay, for an example, let me show you this. Okay, there is a hello.exe. Okay, hello.exe, and uh, let me show some of its attributes. Hello.exe is there, and its hash is MD5. Okay, MD5 hash is this one, C8 something. So basically, I wrote a signature like this. Okay. So it tells hello. Okay, the rule name is hello. So this is a Yara rule, syntax of Yara rule, and this is the condition. It tells hash of the file is okay. File is this one. So what it tells also tells 0 to file size. So it means you are taking the hash of entire contents of the file, entire contents of the file, okay, end to end. Okay, so basically in this case, what is happening? You are scanning the file from the starting to the end. Okay, so which is a problem, right? So if I scan it, hello yara.exe minus r stands for the rule file name, and after that I specify the rule name, and after that I specify what to scan for. Okay. So you can see here Yara was able to detect. So this is the detection name. Okay, so detection name now spawned up. It says hello.exe has been detected. Okay, but what is the problem here? The problem is here every byte of hello.exe is taken into consideration, hence it will slow down. So let us write a pattern-based signature. So okay, so what is the problem with this kind of signature? Okay, so one of the problems is, say suppose if I add one extra byte, say suppose a malware creates another malware from this, in which at the end always add some extra few bytes randomly. Okay, so just some random bytes without making any sense, just at the end. So that won't make the file corrupt, but when you calculate the hash of each file, your hash should be changed for each file. Okay, so that is the easiest way to make variation of one binary. So if I just write a, say suppose a automation, it can be written. So at the end of the file, concatenate some bytes. Okay, so they can easily evade the antivirus, right? If you have a MD5 designate. So now better rather than this, I write a pattern matching algorithm. Okay, pattern based detection. How is the pattern based detection? So basically I look into the pattern. So what I have done is I have taken the strings of my file. So this is my hello.strings. In this, one of the pattern is this one, 965RRE. Okay, so this is a pattern which is present in my file, and based on this I write a detection. Okay, so I write a detection like this, 965RRYE. Okay, so even this is going to work. And after that I scan it here. So this also detected. Okay, but what is the what difference did it make? So even though if you add some extra bytes later, okay, even though if you add some extra bytes later, or maybe the rest of the pattern change and this is constant, still you can detect the file. Okay, so your signature is more generic, it has more coverage. Okay, so basically MD5 detection, it coverage is very less. Okay, it can detect very less sample. Okay, or you can say unless the hash is accurate, you cannot detect it. Okay, so this signature has more detection. Okay, again coming to performance, this is going to scan for this pattern from starting to end for each of the file. So performance is still a problem, even though detection is more, it has more coverage, but your uh, your coverage is sorry, your efficiency is still less. Okay, so how do we make it more efficient? How do we make it more efficient is by lessening, by reducing the number of files to be scanned end to end. Okay, so each file would be touched by the antivirus, no doubt, but the file should not be scanned end to end. Okay, so maybe if you scan instead of the entire file, if you scan first 2-3 bytes or first 10 bytes or maybe till the entry point, that's fine. Okay, so it would be easier, it will be more efficient. Okay, so how do we make this signature more efficient? So let us, for making the signature, let us make it more efficient. How do we see? Okay, so let me look into the attributes of hello.exe. First is hello.exe is a exe file. Its size is some 1.5 KB. Okay, so if I want to write a generic signature, I should collect many variants of hello.exe and determine the size. After that, check some other attributes like how many, what is the entry point? Okay, so entry point lies here, and entry point, some bytes should be there at the entry point. Okay, so after that, there are two sections. There are text section and data section. Each may be having certain size as well. Okay. So basically, what if I want to make it more efficient? So here is my signature, which is more efficient. So first is, it is a P file. Okay. So P file, how will it find? Okay, so first maybe I put this first, but if I put this first, this would have been better. Okay, so first I check the file less than 2 MB. Okay, in this case, if I take 10 KB also, that would have been better. Yeah, 1.5 KB also, it would have 10 KB, it would have been better. So any file that is beyond 2 MB in this case won't be scanned. So many files would be easily left off. Okay, so those files won't be touched at all by the scanner. Second thing, okay, so P is the file is a P file. Okay, so that is the second criteria. Okay, so this checks whether the file is a P file. Okay, so in this what will happen? So your scanner is going to scan each file till it finds P. That is only few bytes. Okay, that is only few bytes. I talked about the magic header and all the things, how to identify with the file format. So you might have seen in the magic header, if it is a P file, starting would be MZ. In rest of the files like your PDF, percentage PDF was there. Okay, so basically just looking into first few bytes, it will not scan the file. Okay, so you are making it more efficient. Now there will be hundreds of exes there. Okay, so my malware is a exe file. Okay, so I should not scan DLL and all these files. So that also I can put element. Other than that, if you check other in your entire system, many exe would be there, but they would have more or less than one section, more than what two sections. Okay, so here I'm saying another thing, looking into that only two sections is there in the file, then scan it, otherwise leave it. Okay, so you are not going to again scan the entire file, you are only scanning till the file header in case this is a P file. Another thing is check the section names like text section or it is data section. Okay, so if it is a text section or data section, then only scan. If first section is 0 and second section is 1, then only scan it. Sorry, second section is data section, then only scan it. Third, I'm checking at entry point bytes. Entry point bytes tell what is a compiler is. It will help to determine the compiler. So for an example, my compiler has been coded with TCC. So if entry point bytes are this one, I'm checking here entry point bytes also. Okay. So if I check the entry point bytes are this one. So if the malware for which I am writing detection is a TCC based malware, TCC compiled malware, so this signature will help you to avoid scanning any files which are beyond which are not actually which are not actually TCC compiled. Okay, so any VCC plus DB file, everything would be eliminated. Third is I noticed that if I check my other attributes like the in the section, so my pattern like 99RE is in starting few bytes, not rest of the things. Okay. So if I scan only 2 bytes, only 10 bytes of starting of data section, then it would be fine. Okay. So for this, basically, I write my rules such that only first 10 bytes are scanned. Okay, not rest. Okay, so I scan only 20 bytes in this case. So what will happen? It would be more efficient. So first of all these, so we'll call this as filters. All these filters match. Also, if this filters match, only scan this part. Okay. Yeah, the problem is it will be evaded in case the pattern is beyond this, but with time you can adjust. You have to analyze some files and adjust it. Okay, but it won't cause any performance problem. So now what is the problem with byte based detection? First of all, you have to tell, you have to rigorously find the bytes. Okay, like in case of machine learning, you have to tell which bytes. Okay, and again, if you are not looking into the efficiency, so finally it drills down to the patterns only. Okay, so patterns you have to select. Okay, which patterns are malicious or not, and that is kind of manual work only. And bytes I don't say, because from the just looking into some instructions, you cannot say that is a malware. You have to look into other attributes also. Okay, so byte based file scanning applying on machine learning doesn't work in real world. Okay, so even though I know there are papers are there, but in real world that's a problem. Now in the industry, people have gone towards behavior detection. If you want to write detections using machine learning, better choose the behavior that is more efficient, as I told, because of packing rather than focusing on the bytes. Okay, theoretically maybe for a paper you can write it, but in practical real world when you implement product, that can cause performance issues. Okay, so now we'll talk a bit about behavior detection. So here on my system, I'm running a malware that is Ramcos rat. Okay, this is a Ramcos rat. Okay, so this is the Ramcos rat which I am showing you. Okay, so basically it can does some behavior which would be seen in by the EDRs like one I showed. Okay, now we'll talk about memory scanning, which is a kind of behavior detection. So this in Ramcos rat, if I analyze, there are certain strings here in the actual Ramcos rat which is not packed. Okay, so here are some strings in the actual Ramcos rat. Okay, RMC client, RMC stand for Ramcos, RMC Ramcos logs dead. Logs dead that day we saw that Ramcos creates a logs dead on the system, which is basically for logging all the keystrokes and everything. Okay, so now uh, these patterns should be present in the file which is unpacked. Okay, so I have a Ramcos.rat file here. Okay, Ramcos.rat file here, but it is in packed form. If I check with bin text, I don't think any of the patterns should be there. Okay, so if I check for RMC here, okay, it is there. Okay, let me see for logs. So it is packed only. It is unpacked only. So, but logs.dat is not there. Okay, but in uh, but if I check the memory, there are many other strings from, let me check another thing, RMC. So RMC hyphen is also not there. So basically the mutex created by the Remcos rat is RMC hyphen, okay, which is present only on memory created at runtime. RMC client is there in the static file, but all these rest of the two patterns are not present here. Okay, so this is not packed. Even if it is packed, even if it is not packed, some things are created during the runtime. Okay, so basically I wrote a signature covering these few files. Okay, so let me show you the few patterns. Sorry. So if I show you my Remco signature, so it looks like this. Okay, I have the pattern here. So now this pattern, since logs.dot it created runtime. Okay, so but every Remcos has this, and this is created runtime. If I scan it, it is not going to work. Okay, so if I scan it here, it is not going to work because two of the patterns are missing. Okay, two of the patterns logs.dat and RMC hyphen is missing. Okay, so now if I scan the memory, which is part of behavior, how to scan the memory with the Yara? So okay, so let us verify whether the signatures are present in memory. So what I've done is I have gone to process hacker, open this particular process follow.exe. After that, gone to memory tab, and I've gone to strings here and check whether those strings are there in memory or not. So I click all of these and search for RMC hyphen. Okay, RMC hyphen is also there. You can see these are the RMC hyphen is there. Okay, RMC hyphen, so many RMC hyphen. Also, let me check for logs.dat. Okay, if you see also logs.dat is also there. Okay, so now if I want to scan this with memory, so Yara also provides memory signature. Okay, so by default, it is not efficient. It is just a memory scanner. So it will ask me for the PID. Okay, so I have to scan the PID. So its PID is 9180. Okay, so if I scan here, 9180. Okay, so it's detected as Remcos remote access tool 9180. Okay, so my process was detected. So if you want to scan the entire system with the Yara rule, you can just write some automation that scans. That basically what it has to do is it will scan every process with your rule. Okay, so that you can automate yourself. Okay. So this was about memory detection and all. Okay. So I stop here. Uh, would like to take questions.
If anyone has any kind of question, please mention them in chat.
Thanks, Pooja. Thanks for reading the book. No questions?
I think there are no questions, sir.
Oh,
Okay. Sir, today Vikas sir was not able to present here due to some unforeseen circumstances. So on behalf of him, I would like to thank you, sir. Your your past your sessions from past few days have been really insightful,
uh,
and we sincerely thank you, sir, for taking your time for these sessions.
Vishwas, okay, so you are telling for PhD scholar where we should do more focus. Okay, see, first choose your subject because malware itself is a big subject. Okay, so it's a lot going on research. Just choose something. Do you want to go for write detection? There are various subjects now. Okay, like for an example, I told Linux malware is there. This Windows malwares are there. Okay, so how to write detection, that can be one area which you get a scope. If where do you want to go? That is the thing. Okay, taking it further. So if you want to go for uh, jobs which are related to EDRs and all, so here you need to learn about writing the components of EDR, antiviruses, all those things. Okay. Machine learning. See, machine learning. I know it's a lot of traction, uh, but this. See, it's not because I have not worked in machine learning, but the thing is, uh, I have some practical experience in the industry, which I feel is sometimes still now machine learning has some problems to related to malware detection. Okay. So it has certain limitation. It's whatever is there till now. Okay. So machine learning, learn it, but I would say do not focus too much on machine learning. Rather, try to figure out how to detect the malware from the very raw stuff. Okay, because those goes inputs to the machine learning and your AI stuff. Okay, without the raw stuff giving you input, giving the engines input or giving the machine learning input, that doesn't help. Okay, only going after machine learning won't help. Okay, so I don't say ignore machine learning. Okay, I did not mean by that. Okay, but rather learn the fundamentals which drive your machine learning algorithm and all that. Okay, so learn the fundamentals very clearly. Learn the system very properly. Okay, so whichever system you are dealing with, say suppose Windows, you have to learn properly. Right from processes to everything, you learn properly. Hope this helps. Any other questions you would like to ask? So you can reach me out. Okay, so you can reach me out always. Okay, and just wanted to quickly share. Like somebody asked about the uh, PowerShell fileless thing. Okay, so in my GitHub repo, you can go here. So how the PowerShell works, you can see here. So this is basically a PowerShell script. If you run this, it will download this script and execute from memory. This does nothing but pops up calculator. Okay. So this can also be detected because this script would be present in the memory of PowerShell. Okay. It can be also detected with the help of memory detection. Okay. I think I've put about this in my YouTube channel. Okay. So you can take this if somebody wants to know about PowerShell.